Hello everyone, welcome back to Unacademy's channel. Let's crack IIT-JEE in English. So again, let me inform you about this new channel of Unacademy where we are going to start IIT-JEE course in English. That's very good news for all of you. And let me also introduce myself. So here is my profile. I am Jeetendra Dixit. I did my BTech from IIT Kanpur and I have been mentoring IIT-JEE aspirants for last 11 years. So I teach mathematics and I started basic mathematics yesterday only. And this is the second session in which I'll continue algebraic identities part 2. But before starting, let me also tell you about the Unacademy subscription. So how do you get the subscription of Unacademy Plus for IIT-JEE? And if you subscribe, then what are the features you get? Let me explain all those things for you first, and then we will begin our session. So as you know, Unacademy is India's largest online learning platform. And once you subscribe for IIT-JEE, because this is IIT-JEE channel, so I'm talking about IIT-JEE. But you know, on Unacademy, you can prepare for any exam, be it a NEET or SSC or UPSC. The exam you can think of, you can prepare on Unacademy. So we are talking about IIT-JEE. And if you get the subscription of IIT-JEE, then you get access to daily live classes of all the educators. As you can see, you will get access to daily live classes of all the JEE educators. No matter how did you get the subscription, which code you are using, right? You will get unlimited access. Unlimited means you can follow any physics educator, any maths educator, or any chemistry educator of your choice, or you can join a course also. Also, during the session, you can interact with your educator through chat. You can ask your doubts. You can share images and ask your doubt. And you can participate in poll also. Quizzes are there, live test and quizzes. Live test and quizzes means you can participate in quizzes which are topic wise also, and combined test, PCM test, as you give in offline coachings also. So all these things are available once you get the subscription. All these courses are well structured. When I say well structured, that means that everything is pre-planned. So if you are following a particular educator, then you can see the upcoming lectures of that educator. In fact, you can see the courses running and upcoming lectures of all the educators actually. So which topic is on which particular date and what is the timing? Okay, you can see all those things in advance. So this unlimited access you get once you're subscribed to IIT-JEE. So I hope this thing is clear to everyone. These are the things you will get the access once you subscribe to IIT-JEE. You can download this Unacademy's learning app from Play Store. All right. And these are the subscription charges. So let me once tell you about the subscription charges. If you subscribe for 1 month, then it will be 5,400. That too after 10% discount. So actual price is 6,000, but after 10% discount, you will have to pay 5,400. But as you increase your number of months of subscription, that is 3 months, 6 months, 12 and 24 months, then you can see average price, which is given on the left side of the list. This goes down, right? So it becomes very low in these two packages, 12 and 24 months. So you can see 12 months price after 10% discount is 27,000. Then average per month, if you calculate, it will be 2,250 only. And similarly, for 2 years subscription, it is just 1 year price plus 1 month. If you add these two prices, you'll get this one, right? So if you add this plus this, you'll get this price, right? 2 years. So obviously, it is economically best. This is the best package we are offering. And average also, you can see this is 1350, 1350. Which is the least, right? You can imagine. So you're getting the best quality education on this platform by paying just 32,400 for 2 years, right? So you'll get access to India's best educators on this platform on Academy Plus once you're subscribed to IIT-JEE. Okay. So this was all about the subscription. Now let's start today's session. So I'll begin from the point where I left you in the last session. I already discussed with you this identity, right? We have already done the proving part. So I'll do it quickly again for you. So a square plus b square plus c square minus ab minus bc minus ca is equal to, this is sum of three perfect squares. As you can see, this is a minus b the whole square plus b minus c the whole square plus c minus a the whole square, right? So how did we do it in our last session? Let me remind you once. We started from left hand side, multiply this expression by 2 and divide it by 2. So we'll get 2a square plus 2b square plus 2c square minus 2ab, it will become minus 2bc and minus 2ca, right? Now you can combine, you can make triplets, take 1a square, 1b square and minus 2ab. So you can write a square plus b square minus 2ab together, and then plus b square plus c square minus 2bc. 1a square and 1c square are remaining. So you can club these two terms, a square plus c square, along with this minus 2ac. Okay, so you have got three triplets. Now you can express these triplets as perfect squares. So this is a minus b the whole square plus b minus c the whole square plus c minus a the whole square. So we already have done it in our previous session. This was just a revision. So you can see what were the conclusions. Okay, I'll tell you the first thing, that this expression a square plus b square plus c square minus ab minus bc minus ca is always positive or 0. It cannot be negative. Why? Because you can see it is a sum of three perfect squares. So perfect squares of real numbers are always positive, right? A, B, C are, we are considering all A, B, C, as I told you in the previous session also, that A, B and C are real numbers. Okay, we are not talking about complex numbers at all. So A, B, C are real numbers and perfect squares of real numbers are always positive. So all these three terms you can see right hand side are positive, and sum of three positive numbers will be positive. Okay, so now certainly this is more than or equal to 0. So we can say this is a conclusion that a square plus b square plus c square minus ab and minus bc minus ca is always more than or equal to 0. So I told you about this inequality, and I also told you about the equality. Okay, so which I'm going to tell you in next slide about the equality part. It is always more than 0 or equal to. So when this equality holds, you can figure this out easily, because this expression is equal to a minus b the whole square plus b minus c the whole square plus c minus a the whole square divided by 2, and you are putting this is equal to 0. So sum of three numbers is given 0. So when is this possible? Sum of three numbers 0. This is possible when individual numbers are 0, right? If I write, I have told this in previous session also, that if x square plus y square is equal to 0 and x and y are real numbers, then certainly x must be 0 and y must be 0. Similarly, if you have x square plus y square plus z square is equal to 0, then this means x is equal to 0, y is equal to 0 and z is equal to 0, right? All three simultaneously 0. So here also you can write a minus b is equal to 0 and b minus c is equal to 0 and c minus a is equal to 0, right? That means a is equal to b, b is equal to c and c is equal to a. That means a is equal to b is equal to c. A is equal to b is equal to c. So whenever you have this a square plus b square plus c square, remember this. This is very important expression, or you can call it an equation also. Whenever you have this equation a square plus b square plus c square minus 18 minus bc minus ca is equal to 0, you can immediately write a is equal to b is equal to c. Alright. So this was the first part. Now let's have some problems based on this. First problem is very obvious, right? It is given that if a square plus b square plus c square minus ab minus bc minus c is equal to 0, then what is the answer? So you already know the answer, right? What is the answer of this? You already know that a square, if a square plus b square plus c square minus ab minus bc minus ca is equal to 0, then this means a is equal to b is equal to c. Otherwise, this is not possible. Okay, not possible. So a is equal to b is equal to c is the answer. Now let's move to another problem.
this is again a good problem. So now you have last three terms with positive sign. Okay, it's slightly different from the previous equation. Previous equation in previous equation it was a square plus b square plus c square minus ab minus bc minus c. Okay, is equal to 0. Now it is plus ab plus bc plus c is equal to 0. So now what is the conclusion? See the options and try to conclude it. Okay, I'll give you some time to solve it. So you try it, then I'll tell you the answer. Okay, with proving part. Try it. Make the perfect squares. Like we did in the previous session, previous equation, multiply and divide it by 2, then make the perfect squares. Alright, so I'll tell you how to do it. As this is the similar problem, the only thing is that result will be different. So what is the difference? Sorry, this was the problem. So let's see how to do it. I'll start with this a square plus b square plus c square plus ab plus bc plus ca multiplied with 2 and divided by 2 with the same thing which we did in the previous equation. So now it will become 1 by 2 of this was equal to 0. Okay. So now this equation will become a square plus b square and club it with 2ab. Similarly, pick b square and c square and club it with 2bc. And the last remaining terms will be a square plus c square plus 2ac. Alright. This is given equal to 0. As you can see, in the previous equation it was only minus 2ab, now it is plus 2ab. So there it was a minus b whole square, now it is a plus b whole square. Alright. So write 1 by 2 of, it will become a plus b the whole square plus b plus c the whole square plus c plus a the whole square. Alright. Is equal to 0. Now you can see this is sum of three perfect squares, the same logic which we applied in the previous equation also. Sum of three positive numbers will be 0 if these numbers are individually 0, right? All numbers 0. So that means a plus b is equal to 0 and b plus c is equal to 0 and c plus a is equal to 0. Now see, what are we going to conclude? So get a is equal to minus b and b is equal to minus c and c is equal to minus a. Okay. So for using these last two equations, you can write put c is equal to minus a in the second in this. So from second and third you'll get b is equal to a, right? Now put this b is equal to a in the first one, okay, in this equation. So I have b is equal to minus a is equal to b and a is equal to minus b. Alright. So this means a is equal to minus a or b is equal to minus b. Right? That means 2, if you write a is equal to minus a, that means 2a is equal to 0. That means a is equal to 0. And because a is 0, so b will also be 0, right? Because a is equal to b. And because b is 0, so c will also be 0. So c is 0. That means all three are 0 simultaneously. So all three will be 0 simultaneously. Okay? So that is the only correct answer. A, b and c will be 0. The C option you can see a is equal to b is equal to c. That won't work. Why? Because a, b, c is equal to 1 will not work. A, b, c is equal to 2 will not work. Right? this should be equal to 0. All three numbers should be equal and 0. That was the result. Okay. So when we put plus sign uh, in front of A, B, B, C and C, A, this equation becomes A square plus B square plus C square plus AB plus BC plus CA is equal to 0, and result becomes A is equal to B is equal to C is equal to 0. In the previous equation it was A is equal to B is equal to C is equal to any real number, right? But now it is A is equal to B is equal to C is equal to 0. So I hope it is clear, right? You understand both. I hope you understood both the equations and solutions properly. But yes, one thing is sure, that both the expressions A square plus B square plus C square plus AB plus BC plus CA, or A square plus B square plus C square minus AB minus BA minus BC minus CA, both the expressions are either always positive or 0. They cannot be negative. Okay, that is for sure about both the expressions. Now we have another identity. So this is another identity in which, see, this complete formula A cube plus B cube plus C cube minus 3ABC is equal to A cube plus B cube plus C cube minus 3ABC is equal to A plus B plus C into A square plus B square plus C square minus AB minus BC minus CA. So this is very important formula, very important, right? This can also be written as you know, this can also be written as A plus B plus C. Right hand side you can change. What change you can bring here? You can write this second expression as A minus B the whole square plus B minus C the whole square plus C minus A the whole square. So many questions can be formed on this formula, right? So I'll tell you some questions about this identity. Now see, if I write A cube plus B cube plus C cube, if I say A plus B plus C is equal to 0, then what will happen? Right hand side will become 0, right? Right hand side will become 0 if A plus B plus C is equal to 0. Then that means we'll get A cube plus B cube plus C cube is equal to 3ABC. Similarly, if we put A square plus B square plus C square minus AB minus BC minus C is equal to 0, that means A is equal to B is equal to C, right? Then again we'll get A cube plus B cube plus C cube is equal to 3ABC. Or I can say like this, if A cube plus B cube plus C cube is equal to 3ABC, then what will be the result? If A cube plus B cube plus C cube is equal to 3ABC, that means I am saying A cube plus B cube plus C cube minus 3ABC is equal to 0. So this implies that either A plus B plus C will be 0, or A square plus B square plus C square minus AB minus BC minus CA is equal to 0, right? And using the previous one, we can say that this is same, either A plus B plus C is equal to 0. This is the first result, or you can say A is equal to B is equal to C. So that means if A cube plus B cube plus C cube is equal to 3ABC, so we can conclude two things, not one. So most of the time students learn only one thing, that A cube plus B cube plus C cube is equal to 3ABC means A plus B plus C is equal to 0. No, that is not necessary. A plus B plus C may be 0, or it might not be 0, but A is equal to B is equal to C will work. Okay, it might happen that A plus B plus C is not 0, but A is equal to B is equal to C. Or it might happen that A plus B plus C is equal to 0, but A is not equal to B is not equal to C, right? So both of the results are possible. So what is the final conclusion? Let me conclude it. Whenever you have A cube plus B cube plus C cube is equal to 3ABC, then what will you write? You will write A plus B plus C is equal to 0. Either A plus B plus C is equal to 0, or A is equal to B is equal to C. So that is the result. Okay. The similar thing I have written in right hand side also. I mean in another slide also. In this slide you can see, if A plus B plus C is equal to 0, or A is equal to B is equal to C, then you can write A cube plus B cube plus C cube is equal to 3ABC. We just learned it, right? That means converse of that statement is also true. What is the converse statement? See, I have put this symbol here. You can see this symbol. That means this first statement implies second, This is statement. And if second is given, then this implies first also. That whenever you have A plus B plus C is equal to 0. I'll write all three things. If you have A plus B plus C is equal to 0, you can immediately write that A cube plus B cube plus C cube is equal to 3ABC, okay, without any doubt. Second, if you have A is equal to B is equal to C, then also immediately you can write A cube plus B cube plus C cube is equal to 3ABC. Alright. Third, if you have A cube plus B cube plus C cube minus 3ABC, then what will you write? In this case, you will write either A plus B plus C is equal to 0 or A is equal to B is equal to C. Alright. So you can't say anything, either first or second for certain. But if it is given that A plus B plus C is not equal to 0 and A cube plus, let me write in the fourth point, whenever you have this, if you have this A, B and C are distinct, and A cube plus B cube plus C cube is equal to 3ABC. This implies that A plus B plus C is equal to 0. Because this is not possible, second result is not possible, then first must be true. Okay, first must be true. Similarly, if you have A plus B plus C is not equal to 0 and A cube plus B cube plus C cube is given equal to 3ABC, then I think now you can answer what will you write? What will you write? Okay. If A plus B plus C is not 0 and A cube plus B cube plus C cube is equal to 3ABC, then when is this possible? This is possible only if P is equal to P is equal to C now. Alright. So in fourth and fifth you can see one particular result certainly because the other is not true. Okay? But in third, you have to write both the results. A plus B plus C is equal to 0 or A is equal to B is equal to C. So in many of the questions it is always given that either numbers are distinct so that you can write A plus B plus C is equal to 0 for certain. Okay. Sure. Or sometimes it is given that A plus B plus C is not 0. So that means you can certainly write A is equal to B is equal to C. So this was all about this identity. Now let's begin some questions. Okay. So we'll practice some questions based on this identity and some other logical questions also, because this is a class of basic mathematics. So I'll bring some other examples also to discuss with you. So now this is the first sum. Try it. Try it for a minute and then we'll discuss it. See what is the answer. Try to solve it and check what is the answer. Try it for a minute. We can compare it with the identity we just discussed and try to conclude the answer. Alright, so let's discuss it. So in this we have a cube plus b cube plus c cube is equal to 3abc. Now what is the c? So in place of c we have put 1, right? So 1 is there in place of c. So a cube plus b cube plus 1 can be written as 1 cube, alright, is equal to 3 into a into b into 1, alright. Now you can compare it with a cube plus b cube plus c cube is equal to 3abc. So this is possible. This implies that either a is equal to b is equal to 1 or a plus b plus 1 is equal to 0. Now you can see in the given question that a is not equal to b, right? So if a is not equal to b, that means this we can reject, and after rejecting this must be true, right? This must be true because at least one must be true, right? So a plus b plus 1 is equal to 0 is the answer, and that is the expression we need to find the value. So a plus b plus 1 is nothing but 0. Alright guys, so I hope it is clear to everyone. Now let's move to another problem. Next sum is quite logical. So try to figure it out. What is the answer of this particular question? And then we'll discuss. See, let me also tell you one thing. Yes, obviously you can expand it, but this question can be solved without expanding. It's a logical question. No calculation is involved at all. You can answer it directly. It's completely logical question. And yes, obviously you can expand it and then you can make a quadratic, then you can find the discriminant and after getting an answer. But that is not required. That is not the thing to apply in this particular question. Alright, now let me discuss with you. If it is given, we have already used it in previous questions also. So same logic we need to apply here also. If we have x square plus y square plus z square is equal to 0, then x must be equal to 0 and y must be equal to 0 and z must be equal to 0 simultaneously, right? Otherwise it won't be 0. So again we have three perfect squares in addition. So x minus 1 whole square plus x minus 2 the whole square plus x minus 3 the whole square is equal to 0. So the sum of three perfect squares is given 0, so this will be 0 only if x minus 1 is equal to 0 and x minus 2 is equal to 0 and x minus 3 is equal to 0, right? So it's a contradiction. From first we are getting x is equal to 1 and from second we are getting x is equal to 2 and from 3 we are getting x is equal to 3. That means x cannot be simultaneously 1 or 2 or 3, right? 1 and 2 and 3, right? Because when x is equal to 1, first will become 0, but remaining 2 will be positive. When x is equal to 2, second will become 0, but remaining first and third will be positive. For x is equal to 3, third term will become 0, but first and second will be positive. And for any other value, all three will be positive. That means simultaneously, all three cannot be 0. There's no value, there's no common value, right? If we would have got one common value in all three equations, here, here, and here, then for that particular value, all three expressions will have become 0 simultaneously, and then that could be the answer. But we are not getting any common value, so that means there's no real solution for this particular equation. This equation can never be 0, right? It is always positive, so no real solutions. All right. So I hope it is clear. Now let's move to another problem. So if we have AQ plus BQ plus CQ minus 3ABC is equal to 0, then which is always true? So this is something which we already did, right? These are now straightforward question. We already did this last part is A is equal to B is equal to C. Always true. Focus on this particular word. Always, okay? So always. Can we say that A plus B plus C is 0? Always, whenever AQ plus BQ plus CQ minus 3ABC? No. No. Can we say A is not equal to B is not equal to C? No, not necessarily, because for A is equal to B is equal to C also it is true. So yes, this is not always true. Always. Can we say that A is equal to B is equal to C always? No, not necessarily, because A plus B plus C can be 0, right? We can't say this because A can be equal to B can be equal to C. Yes, but we can say this, right? Either A plus B plus C will be 0 or A is equal to B is equal to C. So these are the two results. These are the two results out of which at least one will be true. At least one. But exactly one or which one will be true, that we can't say, right? That's why A and D are wrong. That's why A and D are wrong. If you ask which of the following may be true, then it will be true. They will be true because yes, A plus B plus C can be 0. In that A not equal to B not equal to C may also be true, right? You can choose three numbers whose sum is 0 but numbers are different. Then in that case, A, B, C, D all four will become true. If I ask which of the following B might be true, okay? But because we have question is always true, which of the following is always true? So always or only C option, right? Only C. So this was the problem. I hope it is clear. Now let me tell you. Now let's move to another problem. Now this is a good problem. Let's see if you can crack it. One equation, two variables. Can you solve it? One equation, two variables. That means something special should be there. Because obviously, in general, you can't solve such equations in which there's only one equation and two variables. Because you need two equations for two variables, three equations for three variables, four equations for four variables, right? If you want to find the value. But in special cases, okay, in special cases, you can have one equation, many variables, okay? So what is that special thing in this? Try to figure it out. And we are around the same one thing which we are discussing from the beginning. Let's see if we can figure it out. I'll wait. Try it. Alright, so I'll give you another hint. You can make it up. You can make perfect squares. So how to make perfect squares? Let's just start. Let me give you the solution. So if you have a square plus b square minus 2a minus 4b plus 5 is equal to 0, then we have a square minus 2a plus 1 plus b square minus 4b and put plus 4 with this. Okay, so I have split it this 5 into two numbers 1 and 4. Okay, so 1 is written here and 4 is written here, and that will make it a perfect square also. So this will become what? A minus 1 the whole square, so it is a minus 1 the whole square, and second part will become b minus 2 the whole square, right? Again we have reached to this point whenever we have x square plus y square is equal to 0. Again same logic, x must be equal to 0 and y must be equal to 0, right?
Sum of two positive numbers is equal to 0. So what are we going to write? We are going to write a minus 1 is equal to 0 and b minus 2 is equal to 0. So we get some logical questions like this in between the chapters. So be ready. I'm just telling you these questions here so that whenever you encounter such questions in any chapter, it can be in any chapter, it can be in any chapter. As I told you, this is basic mathematics. Okay, so a is equal to 1 and b is equal to 2. Okay, and C, I'm putting this and or. Always keep noticing these things and or. Try to notice these things from the beginning. And means these two things are true simultaneously, or means either this is true or this is true. That means at least one of the two will be true. They might be this time, they might be true simultaneously also, but we can't say that if it is or. Okay, so in this case I'm writing clearly and this is 0 and this is 0, both must be 0 simultaneously. All right, so always focus on these words or and. Okay, or and. All right, now let's discuss another problem. This is a good problem. Let's see if you can crack it. We need to find the ratio of A is to B is to C. So again, from one equation we can find the ratio of two variables. Okay, that too in special cases if it is homogeneous equation. So I'll tell you about this homogeneous equation later. But from one equation you can't find the ratio of three variables in general. For that you need at least two equations. In fact, exactly two equations, and that too homogeneous equations. But in special cases you can find the ratio, right? That means one equation, three variables, and you need the ratio of those three variables. Then there must be something special in this equation. Okay, so what is that special part? Think about it. Try to analyze it, try to figure it out, then I'll discuss with you. Getting anything? You can try to make perfect squares. That's a hint. Try to make perfect squares. Okay, try to compare it with a square, right? Because we are using a square plus b square, a, b, c in this expression. So, as you remember, x square plus y square plus z square minus xy minus yz and minus zx is equal to 0 implies that x is equal to y is equal to z. All right. So let's see. Can we compare with this? Yes. So a square as it is 4b square, right? 4b square as 2b, the whole square, right? 9c square is 3c, the whole square, minus 2ab, that means a into 2b minus 6bc, so minus 2 into b into 3 into c, I mean 3c, and minus a into 3c. Okay, now compare it with x square plus y square. So this is x, this is y, and this is z, right? X is a, y is 2b, and z is 3c. So now you can compare and you can read it as x square plus y square plus z square minus xy minus yz minus xz, right? You can compare it with this equation, and now you can write this implies that a is equal to 2b is equal to 3c. All right, the same equation which we did in last session, also in the beginning of this session also, right? A square plus b square plus c square minus ab minus bc minus c is equal to 0 and a is equal to b is equal to c. So we are using that equation, and we have written a is equal to 2b is equal to 3c. And now how to find the ratio? Divide by the LCM of these numbers 1, 2 and 3. So what is the LCM? LCM is 6. So you'll get a upon 6 is equal to b upon 3 is equal to c upon 2. So what is a is to b is to c? So a is to b is to c is nothing but 6 is to 3 is to 2. All right, that is the answer. So b is the correct answer. All right, guys, got it. So this was the right answer. Now let's move to another problem. It's a good problem. Let's see if we can crack it. Such problems are important for exams like KVPY and NTSC second stage. So if you are going to write in KVPY in a class 11th, then such problems, identities are very important there. They generally usually use these identities and frame questions like this. Compare it with that a cube plus b cube plus c cube is equal to 3abc uh, is equal to 0 identity equation. What was the condition? Okay, now let me solve it for you. So if you take this a minus b as x, you take x is equal to a minus b and put this b minus c as y and z as c minus a, right? Then this expression is nothing but x cube plus y cube plus z cube upon x, y, z, all right? This is the expression. You need to find the value of it. Now see, what is the relation between x, y, and z? If I add these three numbers, these three equations actually, x plus y plus z, I will get, see, b will be cancelled, c will get cancelled, and a will also get cancelled. So this right hand side is 0. That means I'm getting x plus y plus z is equal to 0. So whenever you have this x plus y plus z is equal to 0, you can write, you know that you can write this means x cube plus y cube plus z cube is equal to 3xyz, right? And now divided by xyz. So you have got the answer, right? So x cube plus y cube plus z cube divided by xyz is equal to 3. All right. So 3 is the answer. 3 is the correct answer. So this was the problem. Okay. Now let's see another problem, similar type. Let's see if you can figure it out. All right, so what are we going to do in this particular question? Like in the previous question, we'll take x is equal to a minus 2, y is equal to b minus 2, and z is equal to c minus 2. So now this expression will become, what is this expression? See, this is x square upon yz plus y square upon xz plus z square upon xy. Okay, we need to find the value of this, which can also be written as, if you multiply and divide by x in the first, multiply and divide by y in the second, and multiply and divide by z in third, so you'll get x cube plus y cube plus z cube upon xyz. All right, so you need to find the value of this. It's the same expression, right? A slight difference in writing the expression. And also you can see the result is also same, because x plus y plus z is nothing but a plus b plus c minus 6, and a plus b plus c is given 6, so it is 6 minus 6, which is 0. So because x plus y plus z is 0, so you can write x cube plus y cube plus z cube is equal to 3xyz, and then finally you can write this is equal to divided by xyz, so it will be 3. All right, so 3 is the answer again. Same question, same type of question. So answer is 3. All right. So this was another question based on the identity which we learned today. So these were very important identities, and as I told you, these identities are good for exams like KBPY. Now in the remaining time, let me tell you about one important expression, and I just want to know if you can factorize it. So if you have this x raised to 4 plus x square plus 1. So next identity we will do tomorrow, but before that, let me finish with this. Do you know how to factorize this particular expression, x raised to 4 plus x square plus 1? Again, it's an important expression. I'm saying this is important because factorization of this particular expression is used in a lot of chapters, okay? In algebra, even in calculus, right? Even in coordinate geometry, because in coordinate geometry also you use algebra. So use algebra a lot in all the sections, in all the units. So this expression is very important. I want to discuss about factorization of this particular expression here. So let's see if you can crack it. Hi, Sujit. Hey, sir, you are writing x square only? No, no, no complex number is involved. No complex number. Coefficients will be real. Okay, coefficient should be real. That is the main purpose. Coefficients will not only be real but integers as well. I'm telling you, integers as well. If I give you a hint, then you need to make it a perfect square by adding and subtracting something. Try to think about it. All right, I'll continue. All right, I continue. So see this can be written as x raised to 4. If I add plus x square in this will become a perfect square. 2x square plus 1, because I have added plus x square, so I'll subtract x square as well. So now you can see this part will become a perfect square, which can be written as x square plus 1 the whole square minus x square. All right, so you can write this x raised to 4 plus x square plus 1 as x square plus 1 the whole square minus x square. Now apply the formula of a square minus b square. So a square minus b square is a plus b into a minus b. All right, so using that you can write this x square plus 1 plus x a plus b into a minus b, which is x square plus 1 minus x. All right, so it will be x square plus x plus 1, and second term will be x square minus x plus 1. All right, so this is the way to factorize it. All right, so these factors are very important. We are going to use these factors in many chapters. Try to remember this expression. Okay, I'll write it again. I'm asking you to remember this: x raised to 4 plus x square, and if you don't remember it, then at least remember the method to factorize it. Okay, that is also good enough. At least remember the method to factorize it. So this is the result which we need to remember. All right, now one more formula I'll start today, and we'll do some questions based on that tomorrow. So let me tell you the formula first. This might be a new formula for class 11th students. A raised to n minus 1, you can call it an identity also. I will generalize it later, but I am writing in this form. A raised to n minus 1 can be written as a minus 1 into a raised to n minus 1 plus a raised to n minus 2 plus a raised to n minus 3, and so on up to a plus 1. All right, let me explain. Proving part we'll do tomorrow. Let me do some examples. If you have like x cube minus 1, okay, if you have x cube minus 1, it will be x minus 1 into x square plus x plus 1. All right, x square plus x plus 1. Now suppose if you have x raised to 4 minus 1, obviously you can write it like x square minus 1 x square plus 1, but we are factorizing in this way. Okay, so this is in this way it will be x minus 1 into x cube. It will start from x cube in second bracket, x cube plus x square plus x plus 1. All right, you can further factorize this also in this case, in this particular case, because you know there's another way of factorizing this x raised to 4 minus 1. So whenever n is even, you have two ways to factorize it. But when n is odd, then that is the only way to factorize it. Okay, so this is the only way to factorize it. But for even and odd both, you can use this formula. You can use this formula for both n, when whether n is even or n is odd. All right. So similarly, if you have x raised to 5 minus 1, you can write x minus 1, and remaining it will be x raised to 4 plus x cube plus x square plus x plus 1. All right guys, so I hope it is clear to everyone. So in this way we can factorize it. I will tell you the factorization of this particular expression, and in fact we will generalize it. I'll tell you the factorization of a raised to n minus b raised to n in next session. So those formulae will be important in complex questions, in advanced level questions. We use these formulae. So before starting any topic or inequalities in our next session, I'll complete these formulae in tomorrow's session. That will be on algebraic identities 3. All right, in that I will continue it. I'll also tell you the factorization theorem. This is called factor theorem, and using that we'll factorize other polynomials also, like factorization of cubic or factorization of some other higher degree polynomials. Okay, so we'll complete that factorization part and this formula in our next session. Okay, all right. Well then, take care. Bye bye. And of course, subscribe the channel Let's Crack IIT-JEE in English, and like my videos. And my code is JEET1. I'm repeating it. My code is JEET1. So if you subscribe, if you take the Unacademy subscription plus subscription, then you can use this code to get 10% discount instantly. All right. Thank you very much.